Today's video starts on page 15 in your 5C packets, and it is a problem of the day page. I'm going to start 17, 15, and 19 for you. So I look at number 17, it doesn't have distributing, but it does have move the smaller variable. So I'm going to move 1/10 x over to the right side because that's smaller than 3/4 x. Get a common denominator and subtract those, keep going. Number 15, I'm looking at this and I've got m's on both sides. And negative 1 8/10 m is smaller than positive 4 2/10 m. So I'm going to add 1 8/10 m's to both sides. Cancel those, and I get 6.0 or 6 and no tenths, so 6 m's minus 6/10 equals negative 1. So you keep going with that one, not too bad. Make sure that you check your answer on a calculator at least. Number 19, I don't like distributing fractions, so I'm not going to. I'm going to multiply both sides of the equation, or the only two terms. This whole left side, that's a single term, and 7 is a single term. So I'm going to multiply both of the terms by 2 and therefore clear that fraction out in front. So I multiplied the left side by 2, it cancels the 1/2. So now I just have 3x minus 4 equals 14. And very simple two-step equation now to solve. So you finish that page and then pick up the video. So stop the video, finish this page, do it on your own. We'll go over it in class. So we've got back to some word problems. Now we did word problems way earlier in the year, so you may have to go back and think about all these things that we've been doing and how to set up let statements or writing a model, drawing a bar model, making a table or a diagram instead of let statements. So you can do any one of those 4 kinds of things. I'm going to do a couple on each page over the next couple pages. Then in class we will finish this. I like question number 3. Find 2 consecutive odd integers. Consecutive meaning in order, in a row, right after each other, like x, y, z are consecutive letters. Odd integers, integer meaning it's got to be a whole signed number, and it's got to be odd, so like negative 20, negative 22, and negative 24 are odd integers that are in order, consecutive order. So find 2 consecutive odd integers whose sum is negative 8. So I'm going to write let statements. Let x equal the first, and I abbreviate consecutive, odd, and I abbreviate integers. So cons odd int. Then the next odd numbers, think about it. 1, 3, 5, 7, 9, they are 2 apart from each other. So I'm going to add 2 to my first one, and it will get me to the second consecutive odd integer. And that's how consecutive integer problems set up. The let statements are very simple. So it says, whose sum is, that's the equal sign, negative 88, excuse me. So I'm going to add my 2 let statements, x first, plus the second, x plus 2. Their sum is, equal sign, negative 88. I've got like terms here. So x plus x gives me 2x plus 2 equals negative 88. I'm going to subtract 2 from both sides, and I get 2x equals negative 90. Divide by 2, and I get x equals negative 45. So then adding 2 to this, my first odd integer is negative 45, so x plus 2. I have 2 let statements over here, so I need to have 2 answers here. So Adding 2 to that negative 45 will give me different signs. Subtract, I'm going to get negative 43. If I add those two together, if I do it like a little mini check here, I'm going to get negative 45 and negative 43 gives me negative 88, which is what I want. Yippee. It does work. So the two odd consecutive odd integers are negative 45 and negative 43. Grandpa's age is 6 years less than 6 times Junior's age. Whoa. The sum of their ages is 78. Okay, so they add together to be 78. Find each of their ages. So let x equal Junior's age. So 6x, 6 times Junior's, less by 6, that's going to give me Grandpa's age. So I'm just going to say GPA's age. The sum of their ages. So if I add Junior plus Grandpa, 6x minus 6, I'm going to get that they add to 78 years of age. So I have like terms here. X and 6x gives me 7x. Take away 6, I get 78. I'm going to add 6 to both sides. And I get 7x equals 84. I have to come over here. So 7x equals 84. It's a multiply equation. I'm going to divide by 7. Cancel those, and I get x equals 12. I have two let statements here. So 2 of these, which means I need to have 2 answers here. So 6x minus 6. 6 times 12 is 72, minus 6 is 66. And 12 and 66, real quickly, oh yes, that adds to 78, so I did a little mini check. Grandpa is 66 years old, and Junior is 12 years old. And together, the sum of their ages is 78. Grandpa is 66 and Junior is 12. I'm going to do number 9. 3 times the sum of, ooh, I hope you raised your parentheses there. 3 times the sum of a number and negative 7. That's the parentheses problem. We talked about this earlier in the year. Is, that's the equal sign, 12. Find the number. Let x equal number. I only have one let statement here. So I'm only finding one thing. Find the number. 3 times the sum of a number, which I'm calling x. Summing is adding. Negative 7 is 12. I know that 3 is a factor of 12, so I can factor this instead of distributing this. I'm going to do division instead of multiply, which is the distributive property. So I get x and plus a negative 7, that's just negative 7, or x minus 7 equals 4. Nice, easy breezy equation now, and I get x equals 11. We do a little mini check here. 11 and negative 7 is 12. Well, 11 and negative 7 makes 4. So 3 times 4, yes, that is 12. That does check. Okay, so I know that's right. Find the number. Here's my symbol, sentence answer box label. The number is 11. On the next page, I like number 11. The smaller of 2 numbers is 3 less than the larger. The smaller is. So so I know something about the smaller and nothing about the larger. Okay, so here's my let statements. The next sentence, twice the larger plus 4 times the smaller is 36. That's my equation. Let x equal the larger. That's the thing I know least about. And the smaller is 3 less than, well, 2 words that mean subtract, so that's minus 3. 3 less than the larger, so that's easy. Well, x minus 3 equals the smaller. Now, got to do something with these let statements. Twice the larger, I called the larger x. So twice larger x plus 4 times the smaller, 4 times the smaller, oh, parentheses, because it's not one thing, it's 2 things. It's an x minus 3, it's an expression, is 36. So I have to distribute first. Here's a distributing question. So 4 times x, 4x, 4 times negative 3 is negative 12. 2x plus 4x minus 12 equals 36. Got like terms, so 4x and 2x makes 6x minus 12 equals 36. Now I'm down to 2 operations. I'm going to always add or subtract first. And I get 6x equals 48. And when I divide by 6 on both sides, I get x equals 8. Again, I have 2 let statements here, so I better have 2 answers over here. X minus 3, 8 minus 3, that would be 5. So I think the 2 numbers are 8 and 5. Let's check. Smaller of 2 numbers is 3 less than the larger, which that's true. Twice the larger, so twice of 8 is 16. Plus 4 times the smaller, 4 times 5 is 20. When I sum those together, yes, I do get 36. So there's my check. It works. That find the numbers are 8 and 5. Numbers are 8 and 5. I like number 13 too. The first of 2 numbers is 9 more than the second. I know something about the first. 3 times the first is equal to 7 more than 5 times the second, which I called x. I'm going to call it x. Find the numbers. So I have 2 let statements. Let x equal second number. I'm going to draw a hashtag there. That means number. Second number. The first of 2 numbers is 9 more than the second. So x plus 9, that's the first number. Okay, so we've got our let statements. The next sentence is our equation. 3 times the first, well, I called that x plus 9. 3 times that first is equal to, that's the equal sign, 7 more, okay, 7 plus 5 times the second, which I called x, equals 7 more than 5 times the second, 5x. Okay, got to distribute, so I get 3 times x, 3x, 3 times 9 is 27, equals 7 plus 5x. Move the smaller variable, I don't have like terms, combining like terms, so on to the next step, move the smaller variable. 3x is smaller than 5x. I get 27 equals 7 plus 2x. I'm going to subtract 7 from both sides. And I get 20 is equal to 2x. And when I divide by 2, I get 10 is equal to x. 10 equals x, so I've got, again, 2 let statements here. So I'm going to answer the second one, x plus 9, 10 plus 9 is 19. And if I check them, let's see, 3 times the first, which I called the x plus 9, 19. So 3 times 19 is equal to 7 more than 5 times the second. The second one was 10. It's equal to 7 more than 5 times 10, which is 50. 3 times 9, oh, that's 57. Yes, 57 equals 57. It works. Good. So the numbers are 10 and 19. So make sure you did that problem of the day page already, and we will go over the rest of these and finish these pages in class tomorrow.